one. Now notice that this is a counter current heat exchanger, right? So we're going to plug in some values. We'll just plug in 200 to 150. So our entering water is 200 degrees coming across here and coming out at 150 degrees. This fluid is entering at 40 and coming out at 140. We plug those numbers into our formula. We get our differences, which is 110 and 60. So 200 minus 140, 150 minus 40. We plug that into our formula. We get an LMDT on this particular application of 82.5 degrees. So that's pretty cool, right? Now, what we'll do here is compare it to a parallel flow heat exchanger. Before we had the fluids going opposite directions. This one we've got the fluid going in the same direction. So both arrows are left to right. Our LMDTs are going to be quite different. Now we've got a 160 difference and we got a 10 degree difference. We plug that in and make a formula. We have an LMDT of 54.1. So our LMDT is lower for this heat exchanger as compared to the other heat exchanger. Okay, cool. So this is still real basic, right? And then we may have a multipass heat exchanger. You've heard of U-tube or shell and tube. In this case, our T1 comes in, goes inside of a tube, makes a U-bend, and comes back out on the same side. So for this flow path, we have left to right flow, and for this flow path, we have right to left flow, and T2 comes out over here. So now our terminal temperature differences between T2 and T3 are quite different. So we're leaving, and our entering. We plug that in, it would be a very complex calculation. So heat exchanger manufacturers have been doing this a while. And because it's a multipass, we come up with a conversion factor. Part of the heat exchanger is parallel flow, part of the heat exchanger is counterflow. With a 0.86 conversion factor, which we figure out from experience and knowledge, we can assign the 0.86 to that multipass heat exchanger. So full counter current, we end up with an 82.5 in our scenario. Parallel flow, we end up with 54.1, and multipass, we end up with 70.9. And the idea here is to get to this. If we maximize our LMDT, we can have a smaller area of heat exchanger. So area is inversely proportional. Heat exchanger is a lower LMDT. We need more surface area to get that, but we can do that. So let's talk a little. Any questions real quick about LMDT? Let's talk about the heat transfer coefficient. How am I doing on time? Yeah. It will factor into your sizing equation. So you come to us and you say, I want to heat this much water using this much steam. And based on what selection for the application which I come to, then we know, okay, well, we need this much surface area because the LMDT of this metal, because we might need the right metal, and then we use that in our formula to pick the heat exchanger. Thank you for the question.